Hello everybody, my name is Ricardo Rocha. I'm presenting the lab experiment number 1, which is about motion with constant velocity. Here I'm showing you some pictures about the arrangement that I prepared to perform this experiment. I took 3 wooden tables, 2 of them arranged in a horizontal position, and the third wooden table is in an inclined position. I used this as a ramp to release the ball, in order for this to acquire kinetic energy at the bottom of the ramp, and obviously an initial velocity. Then, in this part of the motion, the object is supposed to have a constant velocity, even though we know that this is an impossible situation because the object is feeling a friction with the surface. With this, I want to answer one of the questions in this homework that said that if I could tell what forces are acting in this object when it's moving on this horizontal displacement. The only 2 forces acting on this object are friction with the surface and drag with the air. I need to mention that there's no other force causing the object to move. The object is moving to the left due to the linear momentum acquired by the object after it descended the inclined surface. Then I recorded the video with some help. I will show it twice. The object is released and is moving with a theoretically constant velocity. Then I took this video and I put it into Tracker. First, I defined my coordinate system. Then, with this I need to answer one of the questions in this homework that said that what happens if I reverse the axis. The only difference will be in the signs. Right now, all the positions are negative because the object is moving to the left. If I flip the axis, the result will be positive results. It will be pretty much the same results. So now I will start analyzing the motion. I can see that at least at the beginning of the motion, I have almost a perfect straight line in the position versus time graph, which is a very good approximation for constant velocity. Then I found the initial velocity for this marble. The initial velocity was obtained by subtracting the final initial position, final initial time during the first time interval. Then I divided these 2 results. With this initial velocity, I went to V idle, where I put the information for the initial velocity, which is obviously negative because it's moving to the left. Then obviously the initial position, which is 0 in this case. The mass for the marble is 12 grams, even though I need to mention that this information is very important for this experiment because according to Newton's second law, acceleration is going to be the net force divided by the mass. And since this is a motion with constant velocity, the mass is not important because the acceleration is going to be 0. So it doesn't matter which mass I put here, the result will be pretty much the same. Then I also defined the time interval for the loop to repeat is 1.602. This number is consistent with the last time obtaining Tracker. Then I run the model. The result that I will get is pretty much the same result obtained and analyzed in Tracker. You have to wait a little bit. Here we can see the object moving to the left, just like the marble was moving. And here I have the position versus time graph, which is a perfect straight line. Here we can see that we have a straight line, the object moving to the left. The results seem to be consistent. What it did next was to export the information from the idle and the information from Tracker, and I put it into an Excel document. Here I have time and position obtained from Tracker and time and position obtained from the idle. Then I graphed these two sets of data, and this is what I got. The red line shows the model data, the blue dot line shows the experimental data. Here I can mention that at the beginning of the motion I have almost a perfect motion with constant velocity. The 2 graphs are one over the other. We have a very good approximation of the motion with constant velocity. Then approximately from the time of 0.5 seconds we start having some differences in the 2 graphs. I need to mention that the importance of this experiment is that I can easily predict the position of the object in the future time intervals just by finding the velocity, finding the slope of this almost straight line motion, and with that slope and using the equation for velocity, for motion, for positioning function of time, I can easily predict the position. I'm very sorry for my English and for that annoying sound. I will get a microphone for the next time. Thank you for your attention, and